Open MATLAB by using this icon. Here, this version is called MATLAB R2022B. So while opening this, by pressing this icon, initially it's takes some time to open this MATLAB. Okay, after the open MATLAB, then we can understand what are the different types of uh, operating windows present in this MATLAB. Okay. Like this, it is open, this MATLAB. It is having the three different types of workspace. Here, this is called command window. And here, this is called workspace. This is called workspace and this is called command window. And here, to write the program by using MATLAB, we have to select this icon. That's called new script. So by pressing this, the new script open, and then we have to write the program on the new script. Okay, that is for to write the program. Okay, and this command window, the whatever the program results we will get after running, after simulating, after compiling the program, we will get the results in the command window. And next. Uh, to implement any electrical circuits or machines or transmission lines or any other systems, solar system or renewable resources or any type of systems we can implement by using simulink. By using simulink, we can implement exactly practical system. Is almost is equal to practical system. That system can be implemented by using simulink, by using this icon. Okay, so press if you want to implement, design one system, and that may be motor or generator or any type of. So first we have to go to for select the Simulink. So open Simulink, press Simulink. After press the Simulink icon, it will take some time to open. Okay. After press the Simulink icon, the new window open like this. This is called new window. So in this new window, to design MATLAB Simulink, press this blank model. Press this icon blank model, and again it's take or 1 or 2 minutes to open. And then it's blank model. Like this, it is open. Then here, uh, this is called library browser. From this library browser, we can take the elements, we can take the operate components. Okay. From this library browser, we can select the components. What are the components is required for design of any system. Okay. So this is called MATLAB. And then here, so press this library browser, and it will take some time initially, and then it's open like this. So for example, if you want to know what is that DC voltage source, DC voltage source, if you want to know source DC voltage source, right here, DC voltage DC voltage source. Okay, and then press this icon. So these are the different types of DC voltage sources. Okay, and this right click and add black to model untitled. Here this name of this worksheet is called untitled. That's why. So when you are press the right click on this icon source, and it shows like this, add black to model untitled. Okay, and then that element will be available in this untitled model. Okay, and also it will take some time. After some time, it will be displayed in this drawing sheet. Like this, that DC voltage source present in this is available in this drawing sheet. Okay. Like this, these elements we can select. And also one more in this way also. Another way to get the elements on this worksheet. So to press mouse left click 2 times and write here DC machine, for example, DC machine, and select this DC machine. Okay. And also initially it will take some time. After that, it will be displayed on this screen. Okay, drawing sheet. It is available on drawing sheet. This we'll get this machine. Okay, and in this way. So when you are moving the cursor on this like this, automatically we can connect like this fashion. So while drawing this, while dragging, okay. In this way. For example, if you want to connect the DC voltage source to the armature of the DC machine, okay. So like this. The DC voltage source is connected to the armature winding. And also, if you want to connect this DC voltage source, okay, if you want one more DC voltage source in this drawing sheet, press right click on this DC voltage source and drag left side or right side like this. So that means instead of copy, so we are getting the one more element by pressing right click by using mouse and drag like this, one more element. Like this, we can get get the more elements without going to the library. Okay, so this is the MATLAB. In this way, MATLAB we have to use. Okay, and you want to connect different like this. If you want to connect another way, field winding also like this. Okay, in this way we can connect the elements separately excited. This is called field winding, and this is called field winding, and armature winding of DC machine is separately excited. So open this DC voltage source by pressing 2 times, and then the DC voltage will be displayed. Okay, like this. So what is the amplitude or DC voltages? For example, what is this DC machine? This DC machine, press this DC machine, and here per set model, already predefined model is available. This is called predefined model of this motor, 5 HP, 240 volts, 1750 RPM, and field voltage is called 300. Okay, 240 volts, armature voltage is called 240 volts, so field voltage is called 300, maximum rating of this machine. Oh, okay, for example, supply voltage is called 220. So field voltage, for example, 300, maximum field current. So like this. Okay, this is called separately excited DC motor. And for example, one load torque. To connect to the load torque, take one constant. Take constant. This is called load torque. Load torque constant like this. So if you want to here open this load torque, your constant is called, for example, 20 Newton meters. Apply. Then okay. This is called constant 20 Newton meters. Okay. And then next, if you want to analyze the this motor separately like this motor, take one bus selector like this. Take like this bus selector and connect this bus selector to this in this way. The M is called measurement. Measurement elements available in this M. Understand? So open bus selector, select signals here. Okay. Delete first signal 1, signal 2 remote. remove. First one is called speed in radians per second. Select, and next armature current, field current, electrical torque, Newton meter, like this. Select and then apply. So 4, no? So that's why it display 4. Okay. And take, if you want to display this, what is this? First one is called speed. Right here, take one display, and connect the display like this fashion. Okay. And take one more display by right click on the display and drag like this. And also this way. Drag, right click and drag like this. So in this way we have to connect the DC separately is the DC motor connection. So like this we can connect these elements. Okay. First one, this is called electrical torque. Okay. And this is called field current. And this one is called speed. Okay. So like this we can connect these elements. DC voltage, this field voltage, armature voltage, constant, load torque, and decimation, and these are the connections. And then after the connections, simulate. Press this run icon. Okay. And it's compiling like this, 2% is completed. And here to reduce the compiling time, okay, stop time is there, 10 seconds is there here. So reduce 10 seconds to 1 second, then it will get results very fast. Okay, you want to know where results here. This error is because of this one power guy missing here, right here, power guy. After designing every system, right here, power, select power guy and place here. Okay, this is compulsory, otherwise we will get errors. In this way we have to connect these elements. Okay, this is called speed, armature current, field current, and electrical torque. It's clear. These are the display used to display the only constant fixed value. But if you want to know the waveforms, of this torque waveform and armature current waveform, field current, and electrical torque, take one scope. Right here, scope, and place here scope. Yes, a scope. How many terminals? If you want to display, for example, speed, this is one terminal is required. Am I right? And here one more terminal, here one more, and that means four ports are required in this scope. Am I right? 4 ports are required. That's why to change this is one port is available in the scope. To convert this one port to 4 port, to open this scope. Open this scope. Okay. The scope opens like this, and here under here, this press this icon. The round is there, na? After this file, below file, the one circle, setting circle is there. After this, there is a down arrow, small down arrow is there. So press this and press again. Okay. Here it will shows number of input ports is called one change into 4. Then okay. Okay, then close. Like this. Then the ports of the scope can be changed into 1 port to 4 ports. So from here, connected to the first one is called to want to measure the speed. Okay, connect this port to the speed. And from second one is called, what is the second one? Armature current. Like this. Second one is called armature. Next, third one is called field current. Field current, like this. Then finally, fourth one is called electrical torque. In this way, we have to connect these terminals. Understood? So this is the scope connection. And then simulate again. Simulate here. And after simulation, the results will be shows like this. Speed in radians per second. Radians per second says display. And armature current in amps. Field current in amps. And electrical torque in Newton meters. Okay. After compiling, and then results will be shown. The stop time is called 10 seconds. That's why the graph shows up to 10 seconds. Okay. Stop time is called 10.0. That's why the graph shows 10 seconds. If it is 1 second. Okay. So how much graph is scale is how much you want to require. Here we have to change 10 seconds or 1 second or 0.1 second. Like this. Okay. So this is called results of this motor. First one, speed in radians per second here, 95.41. If you want to convert, take one gain and write 60 by 2 pi in between scope and between display and this bus terminal, speed terminal. Connect one gain and 60 by 2 pi, and then you will get RPM. Okay. So radians per second. And this armature current is called 8.88 amps. Next field current is called 1.25 amps. And electrical torque is called 20 Newton meters. Okay. So like this, separately excited DC motors can be. One DC motor is designed to get the characteristics. And open scope here. Scope. So all waveforms are displayed in only one window. Okay, one figure. So that's why if you want to separate respective waveforms, for example, if you want to draw only torque in one waveform, okay, divide into like this by pressing this icon, and here there is a layout is there. So press layout, and here vertical layout. Okay, select vertical layouts and 4 ports, 4 waveforms. Like this, press, and will be separated in this way. First waveform. This is for speed in radians per second. This speed is called radians per second. This is the speed versus here time. And next armature current. Here 8.88 will get like this. Okay. Armature current. Here because of this 100, 200 range is there. So go to scale and change. It's possible to change range. Okay. And then next, this is called field current 1.25. That's why this is constant. Field current is constant. And next, electrical torque 20 Newton meters. Okay. So you want to display like this. So this is about simulation of DC machine by using MATLAB. Okay.